Hi everyone, welcome to another video. We're looking now at a brand new idea in statistics and data, and this is the idea of standard deviation. Now this is a measure or a number that describes how far values deviate from the mean. So basically when given a data set, we're essentially trying to measure how far all the values are from the particular mean. So from this kind of middle number that we've introduced in the past. Now there's a few steps in calculating the standard deviation. So we're going to do this with a pretty simple small data set. So we have 2, 4, 5, 8, and none. So we have all of these numbers here, and we want to basically calculate the standard deviation. Now what we do is, first of all, we're measuring from the perspective of the mean. So before we do anything, we want to find the mean. And we use this particular symbol to show the mean. And what we want to do is, in order to find the mean, remember we have to add all of the values together and divide it by the number of values there are, I should say. So we have 2 plus 4 plus 5 plus 8 plus 9. And we count 5 values here. So we're going to divide this by 5. And this gives us 5.6. So our average here, our mean, is 5.6. Now, after we've found the mean, there's a few things we want to do. So next, after doing this, we want to find the difference between each value and the mean. This is what we think of as the actual deviation. So step 1 here is going to be to find the mean. The next step is we want to find the difference between each value and the mean. So find the difference between the mean and each of the values. I'll call these each of the data values. So these kind of data points here. So these guys here, now that we have a mean of 5.6, we want to find how far each of these unique data points are from the mean. So what we're going to do, well, we're going to subtract, or we're going to find the difference between each of these and the mean. So here we have 5.6. We've got, we'll start from the largest value. So we have 9 minus 5.6. That gives me 3.4. We have 8 minus 5.6. That gives me 2.4. And we're going to essentially keep going for all of these data points. I'll let you have a go at that, but just so we can be conscious of time, we'll move on to the next step. Now, basically, the standard deviation is defined with this particular symbol. This is the Greek letter sigma. So it's defined as the square root of these differences. So these that we've found here, the difference between all of the data values and the mean. So for example, x1 could be this value of 9 here, minus my mean, I've got with this notation, and we square this. This is just how standard deviation is defined. And basically we add up all of these differences between each of my data values and the mean, and we square them. So here x2, for example, may be my 8. And we're going to go so on and so forth here until we get to the very last one. And what we do here, finally, we divide these by the number of terms there are, n. So in our data set, up here, we have 5 values. So the same thing we divide by in order to give us the mean, we're doing the same. We're dividing by the same number for standard deviation, and it's all going to be under a square root. So let's go back to the data points that we got, and I'm going to just plug in the difference between each of my points, 2, 4, 5, 8, 9, and 5.6. And then I'm going to pop them into this formula. So those are going to be these guys in here. So my sigma here, my standard deviation, is going to be, well, my first value was 3.4 squared, because the difference between one data point and my mean here is 3.4. And then I'm also going to add my next one that I found. That's going to be 2.4 all squared. And I'm going to keep doing this. I'm just going to plug in all of the values that we get when we subtract the data points from the mean. Oh, sorry, the mean from the data. But basically, sorry, I'm a bit short on space here. We're going to get all of these values here. And we put that all under a square root and all over my n, so the number of values I have in my data set, and that's going to be 5. So we get an answer, and I'm going to round this off to 1 decimal place. That's going to give me 2.6. Okay, so this guy here is my standard deviation. So like we said, the standard deviation measures how far my data values in the set are from my mean. So as the standard deviation gets bigger, that means I have a bigger separation. So I have a much wider range in my data. They're going to be further away from the mean. And we'll see how this works with an actual example here. So this is some data. This is just a question from a textbook. But this shows the distance that 17 people in Darwin and Sydney travel to work. So these are just two cities in Australia where I'm from. And this is a back-to-back stem and leaf plot. So we've looked at these before, and just a reminder for how to read these. So I've included this little bit down the bottom here. So our stem is going to be our first digit, like in the tens column, and our leaf is going to be the digit in the ones column. So for example, this value here, we read that as 46, and this is a distance, so we're looking at kilometers. And this little bit down the bottom gives you a little summary of that. So 3 with this line in between it, and 5 means 35 kilometers. Now, we're given on this side some data values here. Now we're given a mean distance for Sydney, a mean distance for Darwin, and we're given a standard deviation here and here for both cities. Now, what this is going to allow us to do, now that we have the mean and we have the mean and the standard deviation, we can comment on the distribution and spread of the data. Now, if we wanted to ask ourselves, first of all, why is Darwin's mean less than Sydney's? We can think about our data. Now, consider Darwin on the left-hand side. The data points are pretty packed in around here. there's not a massive range or a massive spread of data here. It ranges from 2 up to 35. So when we take the mean, it's going to be somewhere in the middle, and we get roughly about 19. Well, it says exactly 19.0 as the mean. So our mean is going to be somewhere in the middle. But remember, we've talked before in previous series on statistics that the mean is sensitive to outliers, or it's sensitive to these really big or small numbers, because when we average out, this can change our mean. So if you look at Sydney, immediately we can see that the data, actually let's pick a different color, is far more spread out. So it's got these really big numbers in comparison of, like 52 or 46 that are bigger than the highest number in the Darwin data set. So these big numbers are going to pull the mean a little bit higher. So anytime, because we're averaging out, anytime we get these really big numbers, they're going to increase the mean. And similarly, when we get smaller numbers, they're going to decrease the mean. So by looking at the spread of the data, that tells us why Darwin's mean is less than Sydney's. Sydney has some bigger distances that increase the mean, that directly affect the mean. Now, another question we may want to ask ourselves is, why is Darwin's standard deviation, I'll call that SD, why is Darwin's standard deviation less than Sydney's? Well, it's less than Sydney's for the exact same reason. Now, Sydney has a bigger mean, yes, but the data is generally more spread out. And some of these extreme values, 52, they're further away from the mean of 27.9 here than, for example, 35 is from the mean of Darwin of 19. So just by looking at the spread of data, Sydney has a wider data set. And those extreme numbers, once again, not only do they affect the mean, they also affect the standard deviation. Because remember, we defined the standard deviation as how far data values deviate from the mean. How far away are they from the mean? You can see where I've drawn this green box for the Sydney data. You can pretty clearly see that we have a much bigger spread, and the data is quite vast compared to the Darwin data. So not only is the mean going to get bigger, the standard deviation is also going to get bigger because the data is spread out. It's not as packed in as the data from Darwin. But this is just a little introduction to standard deviation. We'll be working with this a lot more in later years, but that'll be it for today's video. This is how we can work with standard deviation, how we can calculate it, and how we can use it to describe the spread of the data. So thank you so much for watching, and I'll see you next time.